Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about asymptotic notation. So let's get started. Before we understand asymptotic notation, let's first understand what is meant by notations. So what notation is? Notation is a mathematical symbol which represents some information or a concept. So for example, if I write a plus b, here plus is a symbol. So it's a mathematical symbol. And what it is representing? It is representing that I want to sum a plus b, or I want to add a plus b. Similarly, if I write a greater than b, then here the symbol is greater than. And what it is representing? It is representing that a is greater than b. Similarly, in asymptotic notations, we use some notations like big O, theta, omega to represent information about the algorithm. What we do in asymptotic analysis, we first get the time taken by an algorithm to solve a problem. By using the time taken by algorithm, we get the order of growth of a function. And by using the order of growth of a function, we determine which function is best and which algorithm is efficient, right? So this is the same example we were using in our previous videos. What this function is doing? This function is simply doing square of a number. But I have put one extra condition here, that if the n is divisible by 5, then simply return 0 and do not continue the execution. And in previous videos, we have also seen that in best case, the order of growth of this function is constant, and in worst case, order of growth of this function is linear. Now let me tell you how our asymptotic notations help us in explaining this best and worst case. If I ask you, tell me the order of growth of this function, then you simply tell me that okay, the order of growth of this function is linear or maybe sometimes constant. Why? Because if I pass 5 to this function, then it simply returns 0. It's not going to execute this piece of code, right? If I ask you, tell me what is the order of growth of this function in best case, so you can simply say that if I pass 5, then it returns 0 immediately, so the order of growth of this function is constant. Now if I ask you that tell me the order of growth of this function in worst case, then you can say if I do not pass the multiple of 5, then this code is going to run from 1 to n and it's going to calculate the square of a number. So the order of growth of this function is linear, right? So far so clear. Now if I tell you that tell me in one line that what is the order of growth of this function, then what do you do? Now it becomes difficult for you to tell me in one line that what is the order of growth of this function. This is where our asymptotic notations comes into picture. So what basically asymptotic notation help us? It basically help us to convey the information about the algorithm in one line. So let's understand this with an example. So let's first talk about the big O notation. So what big O notation tells about? It tells about the exact or the upper bound of the order of growth of function. For example, here in this example, if I pass 5 as an input, then it immediately returns. And if I tell you that in best case, I always going to pass 5. So we can say that the exact order of growth of this function is constant. Why? Because we are always passing 5 as input or a multiple of 5 as input. Okay. But what if I do not pass the multiple of 5? Then it always going to run a loop from 1 to n, right? To calculate the square of a number. So we can say that in big O notation, the exact bound is going to be a constant, right? Exact bound is going to be constant, and the upper bound is going to be linear. It means at minimum it's going to take constant amount of time, but in worst case it's going to take a linear amount of time. So we can write the upper bound of this function is 1. What does it mean? We can write this also or we can write this also. Upper bound of this function is n. What does it mean? It means it takes constant order of growth if you pass 5, but it may take greater than constant. It may take greater than constant. So if I write big O of n, it means in worst case it takes order of growth as n. Worst case it takes order of growth as n. but it will not going to be greater than n. It's not going to be greater than n. It's not going to be greater than n. It's not going to be greater than n. At worst case, it takes order of growth of n, and in best case, it takes 1. So we can simply say that the order of growth of this function is big O of n. Okay, so this is all about big O notation. Now let's take about theta notation. So theta notation help us to tell about the exact order of growth of a function. How? Let's see. If I tell you that I am always going to pass multiple of 5 to this function, always. So it means I am never going to pass number which are not a multiple of 5. So I am always going to pass numbers like 5, 10, 15, 25. 5, 10, 15, 25. Now if I ask what is the order of growth of this function is going to be, so you would say that the order of growth of this function is exactly 1. Means constant order of growth. And why constant? Because I said we always going to pass the multiple of 5. It means 5, 10, 15, 20. So whenever we pass the multiple of 5, it simply returns 0, because here we are checking that if n is divisible by 5, then immediately return. So this is where theta notation help us to convey the information about the exact bound of a function. So big O notation is clear, theta is clear. Now let's move on to omega notation. So the omega notation is represented by this symbol, and it tells the exact and the lower bound of a function. If I ask you, tell me the order of growth of this function in terms of omega, then what we can say that the order of growth of this function in terms of omega is, so we can say that the order of growth of this function is omega of 1. Why? Because 1 is the exact bound, right? 1 is the exact bound, and omega of 1 also means it takes constant amount of time, or it can also take greater than constant amount of time. Why greater than constant? Because if I pass 5, then it's okay, it takes constant amount of time. But if I do not pass the multiple of 5, then it's going to run this piece of code, and then it is the order of growth of this piece of code is order of n. So what we can write that in terms of omega, the order of growth is 1, and omega also represent the constant, and omega also means that it takes, in best case, it takes the constant amount of time, but in worst case, it may take greater than constant order of growth, right? So let me recap everything. If we have to convey the order of growth of a function in best and worst case, we can use big O. So in big O, we can write the order of growth of this function is big O of n. It means it takes n order of growth or less than n. Sometimes it takes n order of growth, means the linear order of growth, or it may take sometimes constant order of growth. So we can write less than n. We can also write n square, or we can write n cube also. So it means this. It means the same thing. Means ultimately the highest order of growth is n cube, n square, or n, but it may also take less order of growth. Now, if I ask you that tell me the exact order of growth, and the constraint is I am always going to pass the multiple of 5, then you can say that the order of growth of this function is theta of 1. It means exact bound. Okay, and what about omega? If I ask you that what is the order of growth of this function in terms of omega, then we can say exact or the lower bound. So what is the order? What is going to be exact bound? Exact bound is our constant, and the lower order of growth of this function is going to be also constant. So we can write the order of growth of this function is omega of 1. It means it takes constant amount of time or greater than constant, right? Because it tells about the exact and the lower bound. So lower bound is going to be exact, but it may take constant or greater than constant. So see, in big O notation, we talk about that it takes the highest order of growth is n, and it takes less than n. In theta, we tell the exact bound. It means it always going to be a constant amount of time. We talk about the constant and something greater than constant. So it's always going to be big of n, but it sometimes may take less than big of n. So we can say that sometimes it takes less than n, or in worst case it takes n order of growth, right? So I hope now you have a clear understanding of what is asymptotic notation, what is big O, theta and omega notation, and how to use big O, theta and omega notation. The idea is you can convey any information in one line. Instead of saying the best case, average case and worst case of an algorithm, you can simply say the order of growth of this function in terms of big O notation, theta notation and omega notation. This is it for this video. Thanks for watching. See you in the next video.